chapter 17, and it is about transistors and applications. So here we need to recall some concept of the diode actually. So a diode, hope you remember how it is constructed. Diode, do you remember? For the diode we have like PN. So we have one region, let's suppose this is P, another one is N, like this, right? And if I just write the name, so this is, let's say, P type, and it is like N. So there are two layers of PN, okay? PN junction. So it's a layer of two basically. And here, girls, this is what we call junction, right? This is the junction, okay? So, and this PN, what we also called a PN junction. So here we have two terminals connected, which is anode and cathode. You can see this one. This is anode, this is cathode, and it also have this concept like this. And this is the symbol here. This is a symbol here. This is A, this is K. You can see this one, anode and cathode. So here in diode, we have two layers, P and N. But in case of transistor, we have one more extra layer, okay, which is like either NPN or PNP configurations are possible. Like we have like something like that. So one layer is like this, and one layer is
وجدت لتكتب قصتك المميزة، ونحن وجدنا لنتتبع أسعار الرحلات.
Like this. See now. So how many layers we have? 3 layers. Okay. So this way, now these 3 layers like a sandwich. So here we can have a different combinations. Like we can say this is P, next is N, this is P. So one type of combination is possible, correct? Another one is NPN, another type is possible, correct? You are right. So both are possible. It could be NPNP, like it could be NPN. So their combination is like, so that's this way we have two type of transistors. Okay, this is something. So here so now you can see how many terminals we need to connect it. So there are 3 terminals, 1, 2, 3. So here we can connect these terminals, right? So this is something. So these names are like that. So one is called collector, one is called emitter. So current emits from here, it collect the currents, and this is called the base. This is same for both NPN or PNP. So now you can also see how many like junctions are there now. Can you check it? How many junctions are there? If you check, you will find there are 2 junctions, right? 2 junctions. One is there and another one is here, girls, right? Yes. So it means it can behave like 2 diodes connected back to back, something like that. They are connected like here. So, and we already seen that the concept, or we have understand the concept that how the diode works. So diode works in one direction only, and in order to operate a diode, we have to bias it. How to bias? Either it should be in forward bias or it should be in reverse bias. So there is a condition for that. And what is the condition? Like anode should be greater than cathode, or we can say P type should have voltage greater than the N type, then it will be in forward bias, right? This is the concept. So this is just a basic which I just explained to you. Similarly, girls, in order to use a transistor, we must set up this transistor first in a way, these two junctions. Either I'm talking about this is called base collector junction because it is between base and collector. Another junction is called base emitter junction. Okay, so these two junctions must be configured according to the application. Now what is the meaning of configuration? Yani we have to connect these junctions in a way, either they are in forward bias or they are reverse bias according to the application of the diode I am using it. So I can use a diode as an amplifier, yani it can increase the strength of the signal. Okay, so for that it must operate in particular mode we will discuss. And we can also use transistor as a switch. So for that again, these junctions must be in either forward or reverse. That is fixed, again we will discuss that one. So hope you have now complete idea what is a transistor, how it is made up of, and all these things. So let's see, now we go inside it and then we'll understand this in more detail. So let's start now. So this is a YouTube channel. You can go and just check it. What I just explained to you, it is here, collector emitter junction, and it could be either NPN or PNP. So like we will be just focusing on NPN. PNP is gonna be opposite concept which we will learn here. Actually, they are opposite to each other. So here is the emitter, this is a collector. So it will emit the electrons will go there, it will collect. And how it works basically, the small voltage at the base and voltage or current at the base is basically can control the current between collector and emitter. That is the the role of it. So this is something which we will learn in detail now. So separating these junctions, there are two what we call junctions, base collector and base emitter. I already told you this one. Now this is the symbol of the NPN and this is the symbol of PNP. So you can check both the symbols and hope you can identify the difference. What is the difference? Try to identify. Yes. So bus you can identify one, again another one is different. So the arrow, okay, arrow direction. So NPN, it is outward, okay, it is near to that one, and it is inward bus. So you just focus for NPN, it is like that. So a transistor is now this is the definition of transistor. It is a semiconductor device that controls current between two terminals. Which terminals? Emitter and collector. I told you, between emitter and collector. Based on the current or voltage at the third terminal, which is base. So here we will be applying voltage or current. Based on that, we can control the current between these two terminals. It is used for amplification, yani this is the application of the transistor, or switching the electrical signals, yani it can switch on, switch off the electrical signals. It can behave like an electronic switch, just giving proper voltage, it will on off some devices. Nowadays you people know that IoT's time is there. ACs, fans, appliances are are connected to the internet, and from anywhere you can on and off them. How it is possible? Because the switch is inside the device itself, and that switch is basically, we are having Wi-Fi connected. So Wi-Fi, from Wi-Fi we receive a signal, okay, and that signal can on and off the device, that can electrically connect or disconnect the connections. So this is something how we use these transistors as a switch. Now, in order to understand these two applications, there are some basic important things we should understand, like the biasing I told you. So the DC biasing is important to the operation of the transistor, like which junction has to be in forward, which junction has to be in reverse. So for that, we know that, girls, we have to apply some voltages here, some voltages here, some voltages here, so that the junctions must be set up either in forward bias or in reverse bias. This is something. So two important parameters are there which are called alpha DC and beta DC. These are basically current gains. You will learn later on what are these basically. So first of all, you should understand for a particular application how these junctions should be in forward or reverse. How can we know this one? So this is fixed. You can read it. Like if I want to use a transistor as an amplifier, and I want to amplify the signal. So transistor must work in active region. What is this active region or active mode? In this mode, girls, base emitter junction must be in forward bias, and what is the next? Base collector junction must be in reverse bias. So before using a transistor as an amplifier, we have to set up these two junctions according to this condition. Yani base emitter must be in forward and base collector must be in reverse. So we will be applying our batteries there, DC voltages, so that the junctions will be either in forward or reverse bias as per the application. Then we will apply the voltage which we wanna amplify. Did you get my point? Okay. Everyone is silent today. Is everything okay? Fasting? Nothing okay? Huh? No, okay. Any some problem? Oh, all good. All is good, huh? Okay. Let's see now. So this is one application, as I said, amplifier. Another one is that as a switch. So when we are going to use as a switch, girls, so it is gonna be either work as a switch on or as a switch off. So switch on, both emitter, base, and base collector junctions must be in forward bias. When both are in forward bias, it will behave like a switch on. Another one, off state in digital, any switch off. Both must be in reverse bias. So this is something. So when it is working as a switch on, yani saturation region or saturation mode. What is a saturation mode? When both junctions are in forward bias, we call transistor is working in saturation mode or region. Cut off, both junctions are in reverse bias. Clear? So hope this is clear to all of you, this table. Okay? And each and every conditions. Okay, so this is in more detail. See, for the cutoff, girls, you can see at both the junctions are in reverse bias, and hope you also know that while we are applying a negative voltage and diode or transistor is in reverse bias, so these junctions, if we cross the limit of the negative voltage, what will happen? The junction will break down or not, because there is a limit how much voltage we can apply here, right? But if we cross that voltage, means at that time, what will happen? The junction will break down. Yani, this switch no longer can work as a on, off, just finish, okay? Damage. This is the one. So next table is in more detail, actually, yeah, it will damage. So is in more detail, so mode is here. So breakdown mode is there. What is the breakdown mode? Beyond the limit. Yani we apply the voltage very high that will cross the limit and it will overload and damage the transistor basically. This is linear, this is switch, closed switch, open switch, both should be reverse, both should be forward, this is all about it. So it's same almost, you just more information added there. Now, so DC biasing, yani I just told you we have to set up, we have to make it ready for a particular application. Okay, so this is what we call biasing. So in order to transistor to operate properly as an amplifier, yani we are going to look for the first application as an amplifier. So what is the condition, girls? The condition is base emitter junction should be in forward bias, base collector junction should be in reverse bias. All right, then only this transistor can work as an amplifier. Okay, let's see now. So this is NPN transistor. It means is that this terminal is, okay, also just give the name of the terminals. This is called collector, girls. The arrow where we are connecting, this is called emitter. Okay, this one is called base. So I'm just writing these things. I also, as per the given regions, this is N, this is again N, yani emitter is made up of N type, and this is P, correct? NPN, it is like that, correct? So now, girls, just to make it simple for you, just to make it, easier to understand for you. So this is P type, girls. So P type, do you remember the diode P look like the arrow? This is P, and this one is look like N. Yani this junction which is here could be considered as, for simplicity to explain the concept, is like a diode, because this is P, this is N. Did you get the point? I can just show you that yani, it is like behaving like a diode here, because this is P, this is N. All right. Similarly, okay, yeah. So the reality, it is not like that. We know that, but because it's P type, this is N type. There is a layer between the junction, so it is like a diode actually. Okay. Now, so what is the condition for the base emitter? This is base. This is emitter, and what it should be base emitter junction? It should be in forward bias. So you know that the what is the forward bias condition? Yani base, okay, I'm just writing here, base should be greater than emitter voltage. Am I right? Okay. So can you check how much voltage we are applying to the emitter now? It is connected to ground. Can you see this? Yes. So it is 0. So if I apply little bit positive voltage at the base, it will be in forward bias. So I am connecting here positive voltage. Okay, it could be any voltage. For example, let's suppose 5 volt positive. Is it gonna be in forward bias or not? So quickly it will be in forward bias. Correct. Now, so this is in forward bias, which we have set up now. Just look for the another junction, which is base collector. So base collector, because it is again P type, so it can also be considered as a diode. For the simplicity to explain the concept, this is something like that. So this is P, this is N, and I want to make it in reverse bias. Okay, so we have already set up the voltage at the B. I have to set up the voltage on the C. Okay, so how much voltage I should apply compared to the B so that it should be in reverse bias. So just say greater or less than, yani how much it should be. C should be greater than B. All right, yani you are saying C should be greater than B. Yani if I give here, for example, 7 volts, so we have done like that. Okay, so this is the actually condition what we should look for. Yani base should be greater than emitter and collector should be greater than base. If this is true, the transistor is gonna work in active region as an amplifier. Did you get any confusion, any question, all of you? Okay, so clear. So this is something, yani, okay, we have to set up the, once it is ready, girls, then then what will happen? Then here we will apply AC voltage which we want to amplify. So we will be getting, after amplification, voltage here output. This is something, so we'll see later on. Actually we have removed a lot of things, otherwise this chapter is so interesting, but time is short and these things. So for now, okay, whatever you have, at least I will try to make it interesting for you. So this is something, any setup of junctions. Now guys, just minor change. This is NPN. If I make it PNP, you know what will happen in case of PNP? just minor change. So let's see, I'm using this color now. It is gonna be now P for N. This is gonna be N. This is gonna be P. If this is a situation, right? So the diodes will reverse or not? They will also revert. Now, how it will be like that? Because this is P type. Similarly, this is gonna be reverse also because of this one. Clear? Now, so look for the condition. It should be in forward bias. So at the P type we are applying 0, and at the N type we how much voltage we should apply. So look for the again the concept. Yani B should have greater voltage or less voltage, you have to think like that now. B compared to E should have greater voltage or should have less voltage, so that we can have in forward bias. Okay, so what you said, B should have less voltage compared to E, so that this junction will be in forward bias. Yes, absolutely, you are right. Now this is in forward bias. Now I want to make it in reverse bias. Okay, so we already set the voltage B. Now how much voltage I should apply? Sorry, so C should be greater than B or C should be less than B, so that this junction is in reverse bias. Less, yani B should be greater than C, or we can say C should be greater than B. Yani, so check here please. Is that what you are trying to say, all of you? Okay. Now, can you compare these two conditions, what I just explained to you? Check the change. Try to understand the change. Only greater than is replaced by the less than operator. This is the condition. So we will be just looking for one type of transistor. Another one is, we know that. So most commonly used transistor is NPN. NPN type. So NPN we will be just using, and PNP whatever it is gonna be opposite. We know that one. Its use is actually this one is here. So any question, any doubt here? If you have, you can ask. Okay, so no question here. All right. So you understand that how we set up this transistor in an active region by making base and emitter in forward bias, and base collector is in reverse bias by putting this extra batteries. Now girls, how many batteries I am applying here in order to make it these two junctions forward and reverse? Two batteries, two batteries. Now I'll show you another way to make them in forward or reverse with the help of only single battery and a voltage divider circuit. We'll see this one later on. Okay, for now I just explain the concept to you. Okay, so this is base forward, base emitter. This is NPN, you know that. So what is gonna be changed now, girls? Can you see this one? The battery terminals just opposite now. This is now negatively connected here. This is negatively connected because this is negative now. This is negative. Khalas, for NPN. So this is just change. We revert the polarity of the batteries. Now we can use PNP. All right. Now let's look about the currents which is flowing in all the what you call regions. IB is very small. We know that base current is very small compared to these two currents, girls. And is able, but still, IB is able to control a large collector current, which is IC. Important current relationship for BJT are, you can see here, IE, any emitter current, which is emitting here, is equal to basically the base, and the collector current plus base current. Even you can see by this emitter is connected here. So IE is the total, which is basically the sum of IC current plus IB current, which is here. So this is the formula which we should know. You should memorize it. IE is equal to IC plus IB. Also, two more things which I told you earlier. current gains, which is alpha DC and beta DC, which is like that. So rather than saying like this, I think it's better to if you look like this. Both are current gains. And what is alpha DC? Alpha DC says gain you have seen in op-amps. And what is the meaning of gain, girls? Gain is equal to output over input. Yani how much I apply, how much I receive, how much I give input. Like if I am doing a business, how much I am gaining from that, how can I find how much gain is there? I will see how much I am selling something and how much I am buying something. So based on that I can find the gain. So here is that. So collector current is here divided by IE. So yani how much current we are getting here while we are emitting this much of current, which is basically alpha DC. Okay. Another thing, beta DC is what? Again, output, which is IC over IB in terms of IB basically. So there are two gains, current gains, whether alpha DC and beta DC. Now they have some standard values also, which we can see now. So alpha DC can be considered to be approximately 1. Why can we say it is approximately 1? If you look these meters, girls, you will see that IC is equal to nearly IB because, IC is equal to nearly IE. It is because of IB is so small. IB is so small. So in this equation, girls, if I'm saying IB is so small, just drop it because it's so small. So if we drop it, you will see that IE is nearly equal to IC. If this is the case, and when you put it here, so alpha DC will become equal to 1. Is it? Are you getting the point? This one?
Yes.
Okay. So this way, this alpha DC will be nearly equal to 1. This is an approximation. Another is the beta DC. So for the beta DC, its value typically in the range of 20 to 300. The reason is what is the reason? Reason is IC is very high. You can have an idea from here. IB is very low. So this ratio will be high. Yani its value depend upon the type of transistor you are using. It is made up of which configuration. So its value varies between 20 to 300 actually. So these are three formulas. What are this one and these two? You should memorize it. Okay, we will be using this one in order to calculate the all currents IC, IB, IV like that. Okay, so this is the current. Now next we will look about the voltages. Yani different voltage like VB, IB and all. We will look that one also. So this is formulas and these are the BJT voltages. So here we have discussed already the setup of the and now this is VE is emitter voltage, collector voltage, base voltage. So this is something. So this is VB, yani voltage at this point. VE voltage at this point. VC voltage at this point, like that. Okay. And VBB is the biasing battery, and this one is biasing battery. All right. So these voltages are with respect to the ground, the collector voltage. With respect to ground, because girls, you can see there is a single letter. And if you remember, I told you when we are writing something like VA, it means voltage at point A with respect to ground. Yani another terminal, because our voltage is always measured, it is a difference between 2 points. So when we have only 1 point, another is by default ground. Did you get this point? Do you remember that point? Okay, so it means is that when I am saying VE, it means I am saying the voltage between this point, yani E and ground. When I say VC, it means the voltage between point C and the ground. When I say VB, the voltage between B and ground. It's like that. So guys, first collector voltage. So try to understand this one. It's so simple. What is collector voltage? Yani, what I want to calculate, I want to calculate this voltage from here to here. Okay, so how I will be calculating this one? This is interesting. Look here. What I know. Do I know voltage from here to here, girls? This much voltage. this line is parallel to VCC. Don't you know this one? How much it is? VCC? Red line.
اليوم انت سويتها
اليوم أخذت سنترم وأخذت خطوة للأمام للعناية بصحتك. سنترم.
VCC. Is this equal to VCC or not? Red line. Yes. If yes, if I subtract from this VCC, girls, from this VCC, voltage from here to here, so what will remain with me? Will this blue will be with me? Correct? Yani this will remain. So red, I know. What is red? VCC. And if I subtract the green color, green yani voltage across the resistance. And do you know how to calculate voltage across the resistance? RC into IC. If I subtract this one from the VCC, what I will be getting? I will be getting VC is equal to VCC minus IC into RC. Clear to all of you? Okay. This is VC, how we will be doing. So this is always you have to use this formula. So I'm just writing this one. So you can just note it down, any one formula also which we have to follow. So 1 VCC. Next voltage is what? Let's suppose next voltage is this one, VB, this voltage. So girls, for this voltage, here, see, there are two ways to go from here to here. Either I can follow this one or I can follow this one. I will follow this one, the right loop. Why I will follow? I'll tell you, see. So here is the point, VBE. And if you remember, I showed you here a diode. And when I connected the bias singles, so it means this diode is in forward bias. Do you remember? This diode is in forward bias, right? And so here this equation could be written like that: VB is equal to the voltage between B and E, VBE, plus VE. Just a minute. Plus VE, yani this one plus this one. Is this is the one actually. So VB is equal to VBE plus VE, and VBE actually we know already. How do we know this one VBE? Because this diode is in forward bias, and girls, when the diode is in forward bias, it consumes some voltage. How much it consumes? 0.7 for silicon, 0.7 for germanium. So we know the value of VBE. So it's like that. It will be given in the example. It is made up of silicon. It is made up of germanium. So VBE is given to you. If it is nothing is written there, neither germanium or silicon, default you will consider it 0.7 yani silicon. This is the word. Okay. So this is another equation which we are having now. Two equations. Okay, this is the concept here. So this say VBV. So these two equations you also memorize actually. So the three equations there: alpha DC, beta DC, and what was the third one? IC. You know, IC is equal to IE plus. No, it was emitter. How much we are emitting? IE is equal to IC plus IB. It was like that, or IB. I don't remember. Just go back and check it. Yes, IE. So these three things you have to memorize it. Now, any question up to here? Clear to all of you? All clear. Okay. Good. So girls, I already explained to you about these batteries to set up these junctions in forward and reverse. So now what I'm going to tell you, rather than having these two batteries, I can have only one battery, girls, only one battery to set up in forward and reverse. So how it is that possible? This thing is possible like this. See this configuration. So here we are connecting a single battery VCC. I can also show like this battery, okay, or we can show like this one. So VCC. Now, so we are applying this voltage here, but see, we same voltage is here. Actually, this is the straight line, and we are having here a voltage divider, R1 and R2. You look here, and whatever voltage we are getting here, girls, we are applying here. So actually, how much is VB? VB is equal to the voltage drop across the R2. Am I right? What is VB now? Voltage drop across the R2. And girls, can we apply here voltage divider rule in order to calculate how much is the VB? So voltage divider rule says R2 over R1 plus R2 multiplied by the apply voltage total. So total we can apply here. This is the voltage total we are applying to this, this combination here. So this is the VB actually. So this is so easy. Whenever this type of question is given, R1, R2 and VCC, RC, RE will be given to us. I can quickly calculate VB. Once I calculate the VB, do you remember the formula for VE, girls? What was that? I can say VB minus VBE. I just flip it because it was for VB is equal to VE plus VBE. Do you remember? Yes. So VB, if we subtract 0.7, so we can get the VE, right? After getting VE, we calculated two basically what you call voltages. Still one is remaining. Now, after getting VE, girls, VE yani voltage from here to here. Am I right? This one. Can I say VE is equal to IE into RE? Yes. So we can calculate here IRE. After calculating IE, we have to apply approximation. What is approximation? Which says IC is nearly equal to IE. So this way, I also calculated this IC as well. Correct. So we have calculated these two things. Now, which voltage is remaining, girls? VB clear, VE clear. Then VC is not clear. VC. And what is VC? VCC minus IC into RC. Do you know IC? Do you know RC? Do you know VCC? Which will be given. Just put the value and calculate the VC. So this way we have calculated all the voltages. One current is remaining, girls. Which current is remaining? IB. Correct? So for the IB, girls, you will be given beta DC. So if you know the beta DC, the formula is IC over IB. IC you have already, beta will be given. Can we not calculate IB? Did you get the idea? So this way we can calculate that one. So this type of questions is most probably possible. Yani you have to calculate all the voltages, all the currents like that. Okay. So I will just stop here. Inshallah, we'll continue the next lecture. Okay. And we'll see this one, how it is basically calculated, how we will be calculating like that. So here is the basics is complete basically. Now next we will look for the questions and the solution. One question is there. If you want, you can solve this question or tomorrow we can solve this one. Okay. So this is what I explained to you. All are here and the question is like this. So you can solve this one. Try to solve. I will look for your attendance in between and you can Check it now. Easy, yeah. We just subtract that one. So 2.23 volts. No, Mariam, how it could be 0.32? Yeah. All right. Then one mole is remaining, VC. But for the VC, the formula is this one, right? So we have to calculate IC also. Yani we need IE first. So IE, yes, correct. IE will be VE over RE. Then you will be getting this one. Yeah, 2.32 milliampere. All right. Then after you just put it there, then you can get, yeah, we can apply approximation definitely. IC is approximately equal to IE. Then just put it over there, then you will get this voltages also. Yeah, this is the number.